Alright, so in this problem, I have 7 to the power of x is equal to 7. So to solve this, I'm going to first start by dividing both sides by 7. So then 70 divided by 7 is 10. So I have 7 to the power of x over 7 is equal to 10. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 7 to the power of x over 7 is the same thing as 7 to the power of 1. So I have 7 to the power of x over 7 to the power of 1, and that's going to equal 7 to the power of x minus 7 to the power of 1. Or sorry, 7 to the power of x minus 1, which is equal to 10. Now I'm going to take the log on both sides, so I get log of 7 to the power of x minus 1 is equal to log of 10. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 7 to the power of x minus 1, and I can move x minus 1 to the front. So now I have x minus 1 times log 7 is equal to log 10. Now we want to isolate x, so I'm going to divide both sides by log 7. So in these two cancel out, and I get x minus 1 is equal to log 10 over log 7. Now log 10, that's the same thing as 1, so I have x minus 1 is equal to 1 over log 7, and now I can add 1 on both sides. So I get x is equal to 1 over log 7 plus 1. Now, log 7 that's equal to 0.845. So now I have 1 divided by log 7. And that's going to equal 1.183. So I have 1.183 plus 1, which is equal to 2.183. Alright, so in this problem, I have x to the power of 8 minus 121 is equal to 0. So to solve this, I'm going to first start by rewriting x to the power of 8 as x to the power of 4 times 2. Now I have this minus 121, which is the same thing as 11 squared. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2, that's going to equal x to the power of 4 to the power of 2. Now I have this minus 11 squared is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, this is going to equal x to the power of 4 plus 11 times x to the power of 4 minus 11 is equal to 0. Now this is going to equal x to the power of 4 plus 11 equals 0, and x to the power of 4 minus 11 equals 0. So for x to the power of 4 plus 11 equals 0, I subtract 11 on both sides, and I get x to the power of 4 is equal to negative 11. And for x to the power of 4 minus 11 equals 0, I can add 11 on both sides. I get x to the power of 4 is equal to 11. Now, to solve this, this is the same thing as x squared to the power of 2 is equal to negative square root of 11 squared. And now this means that x squared to the power of 2, sorry, this actually has no solution because I have a number to the power of a positive x, or sorry, to the power of an even number, exponent equaling a negative number. So this is wrong. X to the power of 4 is equal to 11. For this, I can rewrite this as x squared to the power of 2 is equal to the square root of 11 squared. And now I'm going to subtract the square root of 11 squared on both sides. And now I get x squared to the power of 2 minus square root of 11 squared is equal to 0. And this means that x squared plus the square root of 11 times x squared minus the square root of 11 is equal to 0, meaning I have x squared is equal to square root of 11, and x squared is equal to negative square root of 11. For x squared equals square root of 11, x is equal to the fourth root of 11. And this has no solution, so this is my only solution to this problem. Alright, so in this problem, I have x to the power of 3 minus x squared is equal to 4. So I'm going to start by subtracting 4 on both sides. So these two cancel out, and I get x to the power of 3 minus x squared is equal to negative 4. Now, I'm going to, sorry, I did this wrong. I'm supposed to have x to the power of 3 minus x squared minus 4 is equal to 0. So now, to actually solve this, I need to find one solution of x, and then using that solution, I'm going to find the rest. So to do that, I'm just going to plug in values of x until I get a solution. So for x1, that's not going to work. For x equals 2, I get 8 minus 4 minus 4, and this is equal to a 0. So x equals 2 is a solution. So now using x equals 2, I can divide it with this. So I have x to the power of 3 minus x squared minus 4 divided by x minus 2. And then this results in x squared plus x plus 2. So I get x minus 2 times x squared plus x plus 2 is equal to x to the power of 3 minus x squared minus 4. And remember, that's equal to 0. So I have this is equal to 0. So now to solve this, I get two equations. I get x minus 2 is equal to 0, and I get x squared plus x plus 2 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2. That's a simple equation. And now for x squared plus x plus 2 equals 0, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 1, and c is 2. So I get x is equal to negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 1 times 2 all over 2a. And now this is equal to negative 1 plus or minus the square root of 1 minus 8, which is negative 9. Or sorry, negative 7. Now I have this over 2. And this is equal to negative 1 plus or minus the square root of 7i over 2. So these are my three solutions. Alright, so in this video, I'm going to solve the equation x to the power of x is equal to 100. So I'm going to first start by rewriting 100 as 10 squared. So from here, I can rewrite 10 squared as 3.16 squared to the power of 2, because 10 squared is, 10 is the same thing as 3.16 squared. Now, this is the same thing as 3.16 to the power of 4, because these two multiply. And now I can rewrite 4 here as 1.1126 times 3.593. And the reason I'm doing this is so I can write this as 3.16 to the power of 1.1126 to the power of 3.593. And 3.16 to the power of 1.1126 is 3.593. So I get x to the power of x is equal to 3.593 to the power of 3.593, meaning x is equal to 3.593.